But what if you want to ask questions over the wider universe of SPP data points? So in order to do that, you would use O minor search engine. Now, what I'd like to show you now are some examples of things that you can do with in O minor to gather evidence for regulatory relationships between signaling pathway nodes and downstream transcriptional targets. So as I go through these examples, I want you guys to focus on the relationship between how we define the hierarchy of nodes in SPP and how data points are organized in the user interface itself. So for all three nodes, and here we're using receptors as an example, there are three levels. There's the category, the class, and the family. And that hierarchy is reflected in what we refer to here as the regulation report. All right, so I'll start with a use case that concerns a lipid transporter whose decreased expression was recently linked to defective insulin secretion. And here we're going to use SPP to determine if regulation of STARD10 might help us hypothesize a mechanism for known links between cellular signaling nodes and insulin secretion. So let's go to O minor, and to do a single gene search, we're going to use our drop down and select single gene. We're going to select our omics category as transcriptomics, and we're going to begin to enter a couple of key letters of our gene that we're interested in, STARD10, and we're going to select that from our exact matches. And for purposes of this example, we're just going to keep everything at default, but know that all the results were at least a p-value of 0.05 or less. So we click the submit button, and what we see are a number of data points for STARD10 that are downregulated here in blue or are upregulated depicted here in red. And of course, you see all your categories. You see receptors, enzymes, transcription factors, as well as conodes. If you actually click on a data point, you get a wealth of information about that particular experiment. Of course, you see the gene that's being interrogated. You see it was twofold upregulated. You see a p-value significance for that fold change, as well as a description of the biosample that was used, an experiment name, and here we're using a TLR1/2 ligand compared to a vehicle. So let's say, for example, you don't know what P3CKS4 is. We have links here to a bioactive small molecule, and what this does is gives you a link directly to PubChem. So you can find out exactly what P3CKS4 is if you're not already familiar with that molecule. And you can see from its pharmacology that it is a TLR2 and TLR1 receptor agonist. Additionally, what you can see from these data points, down here on the More Information button, is the experimental and data set information for that fold change. So you get the experimental name, which is the treatment versus vehicle here, a description of what that was actually done, the biosample, the species, and you can see what data set that experiment was a part of. Now, also, if you want to go directly and look at that data set to maybe see what other experiments were done, we now have a hyperlinked DOI that if you click it, takes you directly to the data set page and all of the various experiments that were done in that data set. The one we were looking at happened to be experiment 2. All right. Let's go back to our page here. So so that was showing you evidence of the transcriptomic regulation of STARD10. And what I'd like to point out is here we see some evidence for nuclear receptor regulation by estrogen receptor. And here we see 2 blue data points, or in other words, downregulated, And if we click on our information, we happen to see that these are ER alpha knockdown experiments. We also see some experiments treated with 17 beta E2 and ER alpha ligand. And we can see that treated with ligand, these an upregulation of STARD10 in this specific cell line. So what we see is we definitely have some evidence of estrogen alpha regulation of STARD10. So now let's take a look at the cystromics data set. So we recommend that when you switch searches like this, that you reset your filter. And so we're simply going to select single gene, but now we're going to filter on cystromics only. Again, we put in a couple of keywords. We select our gene of interest here. Again, we're going to go default. We click submit. And what we see here now are a number of data points that show protein binding in the STARD10 promoter. So each one of these data points is a ChIP-seq data point for a particular protein. What I want you to notice are all these ER alpha data points in combination with various ligands and other proteins. So you can definitely see there's a lot of good evidence that ER alpha is binding the STARD10 promoter. Okay, so just looking at SPP alone, there is an abundant evidence that the estrogen receptor regulates STARD10. However, we could not find any mechanistic literature evidence, in PubMed for the estrogen receptor transcriptional regulation of STARD10. But what is known from the literature, however, is that pancreatic insulin content is actually regulated by the estrogen receptor. So if you take all of this information in total, and if you visualize STARD10, the estrogen receptor, and insulin as three corners of a triangle, now the literature makes some connections, but SPP forms the third side of that triangle and allows the users to hypothesize a possible mechanistic basis for the ER insulin connection. And that hypothesis may that estrogen receptor is regulating insulin status in part due to its transcriptomic regulation of STARD10.